Okay, we're going to be covering 1.7 compound inequalities. And before we talk about compound inequalities, let's go back to the inequality itself. So what I want you to do is on the side of your notes, I want you to write this down as I'm going through this. That way you understand what is an inequality and how we use it for this section. So you already know what inequality is. It means that it's greater, less than, greater than or equal to, less than or equal to. Now, I'm just saying what they are. It doesn't really mean which direction they are because it really depends on the numbers. So let's go with this example. I have 4 and 3. I want to use one of these equalities. Which one's larger between 4 and 3? We know that 4 is larger. So I'm just going to use one of these examples. So I'm going to say that 4, and this is the inequality I would use. So 4 is greater than 3. So if you forgot how that works, that's what that means. So this represents the smaller end of the number. So we want that to be on the smaller side. So this number here is where the smaller number goes. Now, another thing you need to know is if it has a line underneath. So let's say it has something like this. Okay, so n is greater or equal to 3. That means that n can be 3 or anything more than 3. So if I wanted to know my solution, my answer, n can equal 3. It could also equal 4, 5, and then, as you know, it goes on. It could go to 6 and so forth. Anything equal to 3 or greater than 3. So the first thing is make sure you put this in your notes. That way, it's just something you can reference back to. Some of these topics will come up right now in our examples. Okay? All right. The next thing is we want to talk about what is a open and closed circle. So if you see something like this, so if let's say I have these signs, so if I have the equal or less than, I'm sorry, not equal or less than, greater than or less than sign. So if you see this is considered a open circle. Okay, well that means that we're going to use an open circle when we're going to be graphing these inequalities. So when we start going back to the 1.7, we're going to use an open circle. If you see greater than, equal to, or less than or equal to, so you see the little line underneath with the equal, you're going to be using a closed circle. So closed circle means that we're going to shade whatever we're going to graph on the inequality, and we'll go through those examples right now. But this is the second thing I want you to keep in mind and to write down so you can always reference back to it in your notes. Okay? Alright, so let's now go to 1.7. So 1.7 is compound inequalities. We're going to try to make this very simple. Compound is pretty much two inequalities, and the two inequalities are going to be using the or the and. So here I have two columns. In one side I'm going to be using and on the other column I'm going to be using or. So what is the difference? The difference is that when you use and, you will overlap the inequalities that you're going to graph. Okay, I'll show you an example of that. The or, you are not going to overlap. That's it. That's the only difference. Okay, I'm trying to make this 1.7 very simple and short and to the point. So let's go through an example of how I would do this. So let's say I take two inequalities. The first one we're going to graph is, let's do x is greater or equal to 0, and we're also going to graph x less than or equal to 5. Okay, so let's look how that's going to be on the first one here. X greater than or equal to 0. So x has to be more than or equal to 0. So you see the little line here? We're going to go back and realize this is a closed circle. So we're going to go ahead and draw a closed circle. And we're going to draw the inequality. Since x has to be greater or equal to 0, we're going to turn that arrow and point it towards the right. So it's anything greater or equal to 0, so that's our inequality right there. Okay, so here's the other one. X has to be less than or equal to 5. Okay, so again, it's got the equal sign underneath, which means it's going to be a closed circle. So here's 5. X can be 5 or anything smaller than 5. So that means if I graph it, I'm going to be pointing this inequality towards the left. Now we go back to now we're going to go ahead and do the following. We're going to combine these two with the word and. So we're going to do now X has to be greater than or equal to 0, and X has to be less than or equal to 5. So how we combine that is that these two equations, these two graphing lines, are going to overlap. So if they're going to overlap, it means that right here, where the 0 is, I'm going to show this right here, and then where the 5 is, notice that that's where both of those lines overlap. So I'm talking about this line right here. This one's overlapping with this one right at this point. So they're both touching each other at this point if I were to combine them. So we're squeezing them together and we end up with this common, what's common between these two. So now that means that the inequality is going to be a closed circle. We're going to have a closed circle right here. We're also going to have a closed circle at 5. And everything in between is the overlap. So if I were to put the combination of the word and on this compound inequality, X greater than or equal to 0 and X must be less than or equal to 5, to meet this condition, that means that this would be the graph. Okay? Alright, so that's what the word and means for the compound. Now let's look at or. Now for or, we are looking at something different here. For the or, they do not overlap. Okay, so on this one, we're going to have the following. We're going to have X being, I'll just put it right underneath here. So X is going to be less than -1. And for this one, we'll do X must be greater or equal to 3. Alright, so if you notice on this one here, X less than -1. Okay, so -1 is right here. Now the question is this open or closed? Well, this is going to be open. Notice that if I go back to my notes here, we're going to use an open circle. So here at -1, we're going to use an open circle. Okay, and X has to be less than -1. So that's anything smaller than -1. So that means it's going to be not -1, but anything smaller than -1. So this would be my inequality right here. Now X has to be greater or equal to 3 for the second one. So here's here's 3. It's going to be a closed circle because of the equal sign, and X is greater. So that means it's going to be pointing to the right over here, and anything greater than that. So that's the inequality. Now we're going to combine this. So we're going to say X, it can be less than or equal to -1, or X has to be greater than or equal to 3. So on this situation, we're not going to overlap. We're just going to put them all together under one number line. So we need an open circle here, pointing down to the left to indicate that X less than equal to -1. And then here we're just going to copy this one. And so what you really have is just two independent inequalities, and the X can be either, or it can be one of those two. So that's why the or is it could be less than -1, or it could be greater than 3 or equal to 3. So that's the difference. Okay, so I'm just trying to make this very simple for you guys, and let's go ahead and look at an example of how we're going to apply all this and how that's going to look for the next examples. So here we have problem 1. We're going to write a compound inequality. What compound inequality represents the phrase all real numbers that are greater than -2 and less than 6? Graph the solution. Okay, so let's go through this quickly. We want to change this and so into something we can graph. So what we're going to do is we're going to go ahead and start by writing each inequality. So for the inequality here, we have all real numbers that are greater than -2. So that means n is greater than -2. So you could see that from right here, for writing the inequality, okay? And so we're going to put the word n has to be less than 6. So n, the number has to be less than 6. So first thing we do is we write the inequality. So this is how this would work, changing from words to now writing something in math. All right, the next thing after that is we're going to rewrite n greater than -2 as -2 is less than n. Both of these equations right here, both of these are the same thing. Okay, all I've done is switch them. But since I switched the numbers, I have to switch the symbol. So that's what you're seeing there right now. Okay, now if we move further, now we're going to go ahead and write this inequality. So we changed this second one, and now we're going to go ahead now, and since it has the word and, okay, we're going to combine the n as having it in the middle. So this condition right here, -2 less than n and n less than 6, is the same equivalent to this one right here. So now we have a single inequality to represent the word and. So that's the way you're going to see that. So the word and means that you're combining, and so you're going to end up with n being in between two numbers. Okay, now let's go ahead and graph this. So if I graph this, okay, so here's my graphing line. Okay, I want to graph this. So n has to be n has to be greater than -2. So n has to be more than -2. It's going to be in this case, it's going to be a open circle. Okay, 6 has to be an open circle, and n has to be between those two values. So that means I can shade everything in between. So anything in between those values, okay, is going to work for our solution. So again, the word and is to overlap. Here's our overlap. Here's where they're sharing both of those inequalities. Now let's look at number 2, or B in this case. What compound inequality represents the phrase all real numbers that are less than 0 or greater than or equal to 5? So again, we start by writing each inequality. So all real numbers less than 0, here's our inequality for the first one. And then for the second one, t greater than or equal to 5, that's right here, greater than or equal to 5. So it's using the word or, so we're going to go ahead and use that or, and that means that we're not going to be combining those two, we're not going to be overlapping those equations. So if we have our number line here, we're going to go ahead and follow this. So t is less than 0, open circle, and anything below 0, so it'd be something like this. And for the second one, t greater than or equal to 5, closed circle, including 5, anything further or greater, so that would be turning to the right. So there's our inequality for converting and writing into a mathematical form and graphing that inequality. Let's go on to the next problem. Okay, for problem 2, we are solving a compound inequality involving and. At any point on this video, if I'm going too fast, please go back, review it. So if I went too fast on certain things, go back, listen to the video again. Okay, I'm going to try to go through this quickly. So how do I know it's involving the word and? So I know that it's involving the word and is because I have an inequality right here. N minus 4 is in between -1 and -3. So I know I'm involving the word and. So the way we're going to solve this is really you have two inequalities. You have, so if I erase this side, okay, I have an equation right here, -3 less than m minus 4. So that's one solution right there. But I also have the following. I have this one. I have m minus 4 is less than -1. So this is another inequality. So that's why you get the two answers. Okay, now I'm going to show you how to do this together. Okay, so we're going to do all this equation as one. So I'm going to go ahead and write it. So I'm going to write -3 is less than m minus 4. I'm sorry, m is minus 4, and then this is less than -1. So we're going to treat this as one thing. So what we're going to do is we're going to add 4 here to cancel the 4. And what we're going to do is we're going to add 4 on both sides of the inequality. So one here and one here. So inequality sign doesn't change because we're not dividing by a negative number or multiplying by a negative number. So now I'm left with m by itself here. This inequality does not change. So now I'm going to be able to solve for m. So m can be, well, negative 1 plus 4 is going to give us a value of 3. And negative 1 plus 4 is going to give us a value of 1. So here's our solution. Our solution is m can be more or equal to 1, but less than 3. So now let's graph that solution. So we're going to draw a number line. Okay, I'll put here 0, and I'll go 1, 2, 3, and I'll put 4 right there. So here we have a line underneath, so that is going to be a closed circle. So a closed circle at 1, so I'm going to put a closed circle, and let me do that a little bit better. That was kind of messy. So closed circle, m is greater, m has to be bigger or equal to 1, so it's going to be going this way. So I'm going to be shading this way. Okay, and m has to be less than or equal to 3. That's going to be a open circle, not including the 3, but anything smaller than that. And so here's our graph inequality showing that it's between that range. Okay, so whenever you have something in between here in the middle, what you're going to do is you're going to apply the mathematics, the same thing, the same rules. So I want to get rid of the 4 to solve m. So what do? I add 4, so I use the opposite. So instead of subtracting, we're going to add on both sides, and then we end up with our solution. Okay, that's how easy these are. Okay, let's move on to the next problem. Okay, so here we have problem number 3, solving a compound inequality involving OR. So we have two equations with the OR, so that means it's going to be separated, so it's not going to be connecting these two equations together. So let's just go ahead and solve it from here. So I have 3t plus 2 is less than negative 7. So if I'm going to solve this equation first, so I'm going to go ahead and focus on this one right here. So if I'm going to look at this one right here, the thing to do is to get rid of this 2. So that means that I'm going to subtract 2 on both sides, and I'm left with 3t, and then these are going to cancel, and it's going to be less than negative 9. Next step is get rid of the 3 by dividing both sides by 3, and I'm left with t is going to be less than 9 over 3 is going to be 3, so it's going to be a negative 3. So this is our first solution of our inequality, and of course it's OR, and so we need to solve this one right here. So if we solve now this one, we have negative 4t plus 5 is less than 1. So what we want to do is now solve for this one by subtracting the 5. So this is going to be another two-step equation or inequality to solve, and so the 5s are going to cancel, and I'm left with negative 4t is going to be less than, in this case, negative 4. Right, so the next step is to divide both sides by the negative 4. Now remember, if you divide by a negative, you must change the sign. So I'm going to go ahead and just show you that you have to change the sign. So it's going to be now pointing this way, and the negatives force cancel. I'm left with t being greater than negative, or a negative is a positive, 4 over 4 is 1. So here's our inequality with the word OR, and we're going to graph this. So the first one is going to be a open circle where t, so here's our negative 3 is right here, open circle, and t has to be less than that value, so it's be pointing to the left. T greater than 1, again open circle at 1, and anything greater than 1, so it'd be turning to the right. And there's our inequality. Okay, let's go on to our so for our last problem, we have a word problem. To earn a B in your algebra course, you must achieve an unrounded test average of between 84 and 86 inclusive. Okay, what are the possible scores you can earn on the fourth and final test to earn a B in the course? So if you notice, they give us a the number of tests that we've taken and the scores. So 86, 85, 80, and then the last one we don't know, so we're going to call that T. Alright, inclusive means that we're going to include the numbers of 84 and 86 to be part of our solution. So what we're going to do is we're going to find the average of all four scores, and those scores have to fall between 86 and greater than or equal to 84 inclusively. That's what it means. So it's going to include those values so that we have an equal line underneath the inequality. Well, to find the average, all we have to do is add all of these four test scores and divide it by 4. So we're going to take 86, 85, and 80 plus the T for the score we're going to try to find and divide that by 4, and we have our average. And that has to fall between 86 and 84. Okay, so now we're going to solve for this. We're going to first add 86, 85, and 80 and simplify that. So that's going to give us 251 plus T divided by 4. And that's also going to fall under 86. Alright, to get rid of the 4, we're going to go ahead and multiply all numbers by 4. So multiply this by 4 so that these cancel. Multiply 84 by 4, and multiply 86 by 4. Alright, so if we do that, we're going to end up with 336 is going to be less than or equal to, and the 4's cancel, so it's going to be 251 plus T less than or equal to 86 times 4 is going to give us 344. Now to solve for T, we just want to get rid of the 251. We do that by subtracting everything by 251 here on this side of the equation of the inequality and this side of the inequality also. So that's going to cancel our 251, and so this is going to give us 85, and so 85 is going to be less than or equal to, these cancel, so I'm left with a T, less than or equal to the difference of 344 and 251 is 93. So here's our inequality. Here's our answer. Okay, so anything 85 or above, or anything less than or equal to 93 is our answer. So that would be our answer to finding the scores. Okay, so here we have 2 practice problems for you to try out. Go ahead and pause the video, and then I'll go ahead and show you the answers. Go ahead and try them out, see if you can get the right answers on these, okay? Alright. Here are the answers, okay? We'll see you guys tomorrow, and if you have any questions, bring them up, okay? Bye.